And I don't have time to go over this slowly for you, but just watch it, and you can look at the whole thing on I have it on YouTube if you want to go over it slowly, where you can pause it and such.
What chapter is it?
This is chapter 33.4. So what happens is a virus which has spiky proteins on its surface. Do y'all remember what the spiky proteins on the surface are called?
MHC1?
No.
No.
Antigens. The virus that has antigens on its surface enters one of your cells. Inside the cells, it starts multiplying. The cell, in defense of itself, will take one of the antigens that it's creating for the virus and put it on its surface. Eventually, the cell will explode if it's not dealt with, and the viruses will exit and infect other cells. And inside those other cells, they can multiply. So we have two problems that we're facing here. We have viruses inside cells that are multiplying, and viruses outside cells floating around waiting to get in other cells. And we got to kill them both. So one of the things that can happen is a macrophage, which is a type of white blood cell, or also a dendritic cell, which is another type, will sometimes find and destroy some of these viruses. And when the macrophage eats up one of these viruses, it'll destroy it and take one of the antigens that's on the surface of the virus and display it on its own surface, like a trophy, showing what it caught and killed.
That's cool.
The macrophage will then slowly make its way around into the lymph nodes, where many other white blood cells reside, namely T cells and B cells. The macrophage will present its antigen to the T cells. Basically, what's happening is the macrophage is just bumping into T cells. And these T cells have Y-shaped receptors on their surface. But that one has the wrong shaped receptor, and so does that one. But this one has the correct shaped receptor, and they bind together. The binding of this T cell to that antigen activates that T cell, and it starts to multiply many thousands of millions of times, and forms a whole host of clones. And so they call this type of multiplication a clonal selection theory. And one of the clones is called a killer T cell. It's also known as a cytotoxic T cell. And it will leave the lymph node and go around and start bumping into every cell in your body. Eventually, it'll bump into an antigen and bind to it. And the killer T cell will spray out a chemical. Y'all remember what that chemical is called? A perforin.
It perforates the cell.
And it causes holes to open up in the cell. And then it squirts in another enzyme that you should have read about. No, a granula.
Granzyme.
A granzyme that goes in there and destroys the cell.
I have a question.
Yeah.
So the cytotoxic T cell eventually binds to another antigen, and what happens?
And then it kills the cell.
By what?
By spraying in these perforins. Chemicals that kill the cell. And that way we've destroyed all the viruses that are inside cells. And there are so many killer T cells that every cell in your body gets checked. Some of the cells are called helper T cells. And helper T cells spray a chemical called a cytokine that causes the white blood cells to multiply. And the helper T cells will spray those chemicals on all the white blood cells that they run into, including B cells, which I'm going to talk about in just a minute. You also have memory T cells that hang out in the lymph nodes and in the blood vessels forever, and will quickly destroy this virus if it ever gets back inside your body. You have them by the millions.
What are they?
Memory T cells. I don't think you're going to have time to write all this in notes, Emily Kate, but if you go back and want to look at the video from Friday, I go over it in a lot of detail. I got to do it fast here because we're moving on. The B cells work a little bit differently. The B cells are activated like this. A virus gets inside a lymph node and attaches to a B cell, and then the helper T cell has to come spray cytokines on the B cell. Only then will the B cells be cloned. But it's only the correct B cell that has the right shaped receptors for this virus. These other B cells won't react. So you got to find the right B cell. And when that right B cell is activated, it makes a whole host of clones. One type being memory cells that'll stick around forever, and the other type being plasma B cells. The plasma B cells squirt off Y-shaped receptors that are on their surface. They eject them, they make them and release them. And these are called antibodies. And they float around the body, float around through all the blood vessels and tissues, and they stick to any virus that they come in contact with. Because the antibody is shaped like the letter Y, one branch can attach to one virus, and the other branch can attach to the other virus. Are you girls that are typing, are you typing this stuff?
Yeah.
You're not, are you?
I really am.
They really are.
We're stenographers.
And so this will form a big clump. A big clump of viruses. And that clump can be quickly destroyed by these macrophages, which have now multiplied in number because the helper T cells have been spraying them with cytokines. So you get big clumps of viruses that can be easily caught and destroyed. There's other ways that antibodies kill viruses, but that's one way.
What's the other way?
Well, sometimes when they attach and cover a virus so much that the virus can't penetrate the cell because its receptors can't lock on to the cell. That's another way it gets rid of them. Sometimes it'll just macrophages can see these things better when they got a bunch of antibodies stuck to them, and so it's easier for the macrophages to find. And sometimes it literally punches a hole in the virus. And by the way, I'm using viruses as an example, but bacteria are the same way. Bacteria, just like viruses, can get in the body and cause harm, and can get inside the cells and cause harm. Bacteria can actually go into your cells and start multiplying in there and kill a cell from the inside.
What about larger things like protists? Is it the same thing?
This thing will work against protists too.
Are you Tom Willis SSI 4?
SSI 3.
Don't go to 4.
Who's 4?
I don't know.
I don't know.
I just guessed.
Is there someone that's 4?
I just guessed.
What was
it
that
was
called?
What's what?
Adaptive immunity.
That's the adaptive immunity that vertebrates have, and it's a way that once you catch a disease, you won't ever get sick from that disease again because those memory cells are hanging out. The AP biology exam is huge on this. That lecture might have been one of the most important lectures you had. So if you weren't here for it, go back Friday.
More important than respiration and photosynthesis.
Right up there. Right? Yeah, it's right up there. I just know they ask a lot of questions, and I'll give you some of these questions on future quizzes so you can see what they're like.
This is chapter 34.
Chapter 33.
44?
Chapter 33.4.
No, we mean today.
Huh?
Today, what we're doing.
33.5. Yeah, your test is a week from today.
Oh, I thought it was this Thursday. I almost had a heart attack.
Now, what is a vaccine? Well, a vaccine is when they take a virus. And there's different ways to make vaccines, but one way is just to take a virus and to destroy the DNA that's inside the virus, so that you only have virus shells, and inject a lot of the virus shells into the person, and their immune system will behave like it's been invaded by a real virus, when actually it's only been invaded by shells of viruses, the outer coats of viruses. The viruses can't actually multiply inside the cells. But remember, the immune system is reacting to the antigens on the outside surface. So if you inject somebody with a bunch of inactive viruses, they'll still build up an immune response. And so we see here this little graph. If you inject somebody with this infection, they have a little bit of an immune response to it. If you give them a second exposure to the vaccine, which we call a booster shot, then it really increases their antibody concentration. That's the amount of antibodies floating around in your blood. And you can see it'll stay in your body for a long, long time. This is time in days. So 180 days is 6 months. And this eventually kind of levels off, where you always have some antibodies in your blood floating around there from any disease you've had in the past. And if you ever are exposed to that disease again, the antibodies will quickly attach to it and it will be destroyed and you won't get sick. These antibodies are produced by these memory cells that remain in your body for a long period of time. You had your hit.
So if the body's reacting to the antigens and not necessarily the virus DNA itself, is it possible for there to be a virus without antigens that our immune system would be able to respond to?
There hasn't been one. No, they're all made of protein to be able to get. It's not. I don't think it's possible because you need a protein on your surface to bind with the cell to get inside the cell. Because that cell membrane is impermeable to something large like a virus. You got to get in the cell somehow, and the only way in is to bind to a protein so that the cell pulls you in. So I don't think so.
So when people say that the flu vaccine gave them the flu, like that's simply not possible.
It's not possible. Now they could have, by bad luck, had gotten the flu at about the time they got the flu vaccine, and they think that the flu vaccine gave them the flu.
Just like us.
It's possible that you could get, if the vaccine wasn't made correctly, that they didn't kill all of the DNA, but that's they didn't destroy the DNA, but that's usually not the case. They test for that kind of thing, so that's usually not possible. Yes?
Do vaccines cause autism? I don't think so.
No, there's no proof of that. This is my favorite picture in the book. Breastfeeding.
All the guys are like, oh.
This is called. They talk about in the book. They talk about passive immunity. Passive immunity is when you get antibodies from somebody else. Babies get it by breastfeeding. And so you're giving him the antibodies get in the mother's milk. So anything she's immune to, the baby will be immune to as long as the baby's breastfeeding. So it helps keep your baby safe from disease for a while.
So
that's why one reason why breastfeeding
does formulas have this spot?
Formulas do not.
That's why.
Because formulas usually taken from cows.
Ew.
Cows don't have the same diseases that humans have. So we call that a form of passive immunity.
Always thought it was good.
Passive immunity is when you don't make your own antibodies, you get them from elsewhere. They can also just inject you with antibodies to help kill a disease if your immune system isn't working right. And that would be a form of passive immunity.
So babies have passive immunity.
Babies can get passive immunity from breastfeeding. Yeah.
Is vaccines solely for viruses or can bacteria as well?
No, you could vaccinate for a bacterium too.
So something like from what I understand, like when you get a vaccine, some hurt more than others because when a certain thing is injected into your body responds to that with pain, right? When a foreign body is entering the bloodstream. So like, why would?
Well, you just have nerve receptors in your skin that
Like
they're
totally
necessarily they're reacting to the damage that the needle gets going in.
Feels like you've been punched hard a week after a vaccine.
I thought the body also would respond to foreign.
It makes your
stuff
body
in the
hurt so that
bloodstream.
you know to protect that area.
Well, there's inflammation from any damaged area. I don't know that it's
Like the
necessarily.
tetanus shot, like hurts like really bad.
Yeah.
Or like ache or whatever.
Yeah, as
I don't
opposed
know.
as
Maybe they're injecting more stuff. I don't know why that is. Not sure what this is right here. Oh, allergies. The book talks about allergies. An allergy is basically an overactive immune response. Where, well, we're out of time. But, read 33.5. I didn't get to talk about that very much.